what was it in 2012? So that's 7 years later. So that's why you see the 7 in the exponent. And you plug it out into a calculator and you get that answer, 165,399. Excuse me, 33 cents. For number 1, on the back of the page, you have a 1,240 investment, compounded continuously at 2.85%, and you want to keep it in for 2.5 years. So here's the 2.5 years, 2.5. Here's the rate as a decimal. Here's the initial amount, and this represents compounding continuously. So you put all this into a calculator, and you get 1,331 and 57 cents. For number 2, it's 2,340 at 3.1% for 3 years, again compounding continuously. So here is the simplified exponent after I multiply these two, and that gives you 2,568. 2,568 and 6 cents. For part A, you have the $2,000, the 2.85% written as a decimal right here. For 3 years, you multiply those together and you get this. You put this into a calculator, and this is what you get. That's part A. For part B is the guess and check method or the graphing calculator right now. So I'll set it up right now. So for B, they're asking you how much time for you to double the money. So for double the money would be $4,000. So first thing we're going to do is divide by 2,000. So if you notice, no matter what you start with, when they ask you to double the money, this side here is always going to equal 2. So if they say triple the money, then the left side is always going to equal 3. So it's going to be E 0.0285t. So we're solving for t. If you use a guess and check method, you're going to just try different numbers. Again, 3 years only gave you $2,000, 2,178, and you want 4,000. So I would try like 10, 15, 20 in place of the t, and just try different numbers till you get to 2. Your goal is to get to this number right here, to 2. So I would put in like 10, 20, 30, and then from there kind of work my way to get closer and closer to the actual value, to the number 2. So in this one, we get approximately t equals 24 years. In the next module, we're going to learn how to use the logarithm buttons to solve. But right now, we're going to just say approximately 24 years. And that's close enough. You plug it in here. You put a 24 in place of that t times 0.0285, and then raise e to that power, and you should get something a little bit under 2. So for number 4, you start off with $3,000 and put it in an account that gives you 4.3% interest compounded continuously for 7 years. So here is the 3,000. The interest is a decimal, the 7 years. Because it's compounded continuously, the base is E. And so when you simplify everything, this is what you get, and put it into a calculator, and this is the total. Again, number 5 is a guess and check. Notice I didn't put the 20,000 for doubling of 10,000, because no matter what you start with, if you're going to double it, and when you divide, you're always going to end up with a 2 right here. So because it says principal doubles over here, then I automatically just put a 2 there, because this 10,000 is going to become 20,000, and when I divide, it's going to end up being a 2. So you can just cut one of the steps by doing that. Here's your rate, and we're solving for t. Remember, this is a number, it's not a variable. So again, guess and check. I tried 5, I tried 10, I tried 15, and out of the 3, 10 was the closest, and it was pretty close. It was a little bit under the 2, a little bit less than 2, but for now, we'll just leave it at 10. Okay, we could get closer, like nearest 10th if you'd like try 10.5, 10.2, like that. You can do that. But for now, this is good enough. Again, when we do logarithms, we'll get a more accurate answer. Not exact, but a more accurate. Again, here's the setup for the equation. It's again double. It tells you right here to double your money. What's the rate that you're going to need if you want to keep the number in for 12 years. So now we're not looking for T, we're looking for R. And this is how you set up the equation. Now here I wrote several values of R in decimal. So this would be 3%, 4%, 5%, 6% as a decimal. And I put them into the calculator, and it's actually between these two, but it's closer to this one, okay, than 5. So I'm going to say approximately 6%. So for 7, you're looking for the principal. You're looking for the amount of money you started with. If after 4 years you have $3,500 at 4.5% compounded continuously, how much principal, how much did you start with, okay, in the account? So when you multiply this out, you get 8.18. So I'm going to divide both sides by e to the 0.18, and you just put it into the calculator just like you see it. 3,500 divided by e to the 0.18, and so this cancels here, here, and so you end up with p approximately equal to 29.23 with 45 cents. So here you have, we're starting with 3,000 at 3% for 4 years, compounded continuously. So 0.03 times 4 is 0.12. Put this into the calculator, and this is what you get. For number 8B, it says how long would it take the money to double? And again, remember, it doesn't matter what you start with. If you're going to double it, this is always going to be the case where you end up with a 2 right here. And here's the percent, the rate, and we're looking for T. Now I put several values of T here. 20 turned out too small, and 25 was too big, so I just tried all the different values, and this is the closest. This is the closest that we got. So approximately 23 years. Again, what I mean by closest is I replaced the T with these numbers right here, replace this T right here. And then I just work this out, and I'm looking for the value that's closest to 2. And 23 happens to be it. So now you're looking for how long it's going to take for your money to triple. So again, regardless of how much you start with, when you divide in, if you want this to be 3 times as much, when you divide, you're going to get a 3 on this side. That's why it doesn't really matter what you start with. If you want to triple it, this is going to end up being a 3. Here's the interest rate, and then we're looking for T. Now I tried T equals 20 because if you notice, most of them are around 20 for doubling. So I tried 20 on this one, and it was a little bit too big. So then I tried 19, and it was too small. So the value was actually closer to 20. So I would say for this one, it's approximately 20 years. A little bit less, but it's closer to 20 than 19.